In this video, we'll be looking at the definition of a parabola. A parabola is specifically a set of all points in a plane that are equidistant from a fixed line, we call that the directrix, and a fixed point, we call that the focus. So it's also important to know that the focus is not on the directrix, that there's a separate line and a separate point. So it's equidistant from these two objects that the parabola actually sits. It's very much similar to that of a circle, where you have a circle as a center, and then the set of points that defines the circle is the set of points equidistant from that center point. There's a couple of other things that we want to define. We want to define the axis of symmetry. It's a line that passes through the focus as well as the vertex, and it is perpendicular to the directrix. And then we have the vertex. I should have probably done that first, but that's the midpoint of the distance between the line segment directrix and the focus. So let's go ahead and draw all of these little pieces. I'm going to go ahead and do this in a oblong shaped way. It'll be important for us to remember that most parabolas are either going to be vertical or horizontal in some form. This also helps us define a parabola in such a way so that we might have a sideways quadratic, but it is perfectly fine to have a sideways quadratic. Again, it might not be a function, but it is an equation of a defined parabola. So the first point that I'm going to draw is this point, and then I'm going to draw my directrix going this way. Now, it's important to note that I like drawing my directrix as a dotted line. It's important to reinforce the concept that it's not an actual line on the parabola. It's just a line that helps define it. It might also help if I put an X through my focus point, because, again, that's not a point that's actually on the graph. It's just a helpful defining point of that graph. Now, if I go ahead and find the point equidistant between those two, which is probably about there, right there. So this right here is the directrix. This here is the focus. This point right here would actually be the vertex. Again, if it sits perfectly halfway between in a perpendicular line passing through this, so it might be helpful for me to draw another dotted line here, and that dotted line right there is actually my axis of symmetry. So now let's go ahead with all of that identified. Let me go ahead and draw the parabola. So the parabola is supposed to curve around the focus, okay? So it's supposed to appear something along the lines of that. Now, you might ask, well, those lines don't look exactly equidistant from that focus. Now, you might be right. I might have not drawn it accurately, but what's important is that the distance from the focus to the parabola is a straight line. However, the line from the parabola to the directrix has to be perpendicular to the directrix. So this distance right here should be equal to the distance right here. Now, again, it doesn't look like it's drawn accurately to scale. Again, this is why I'm not an artist, but the point is that the distance from any point that I draw, so way out here, if I draw this point to way out here, then that distance right there should be the same as the distance when I drop it as a perpendicular back to that directrix. So now, this is the idea of what this thing is. Now, I might have a better option or a better opportunity drawing this on a coordinate plane. If I were to put the, say, 1, 2, 3, that right there is my focus. I'm going to put an X, 1, 2, 3. That right there is going to be my directrix on the plane. So that means halfway between those 2 points is my vertex right there. And again, the distance between this point and this point should be equal. The distance between any other set. Now, it's also important to make sure that we understand that when I draw this parabola around this focus, again, it goes up and around the focus, that the distance here is equal to the distance here. But that's not the exact same distance from here down to here. So now it looks a little bit more accurate that this is some distance A, this is some distance A, but this distance, say when I draw the point to way up here, this is some other distance B, and this is some other distance B here. And again, they're not exactly the same. This is the same as this, but this isn't the same as this. So by choosing different points around the parabola, I will argue that the distance changes. So, all of this being said, one more time real quick, here's your focus. This dotted line down here is your directrix. Halfway between those two, in a perpendicular line, is going to be your vertex. Then you will have a line passing through the focus, the vertex, and perpendicular to the directrix. That's your axis of symmetry. All of this information will be asked for in some way or another in the questions. It's just a matter of us determining and defining what we actually have. It's also important for us to be able to create an equation out of these things, which we'll be doing in the next video.